we talk about linear momentum equation, just as we discussed equation for law of conservation of mass. So first of all, what is linear momentum? So as you know, momentum is normally denoted by the mass of the fluid that is under consideration times multiplied by its velocity. So m into v is known as momentum of that particular mass of fluid that is under consideration of course, within a certain boundary or flow field or wherever it's being considered. The momentum of a rigid body of mass m moving with a velocity v is m into v. So they have formally, just it has been written down. And similarly, the momentum equation. So the Newton's second law, which says the acceleration of a body is proportional to the net force that is acting on it and is inversely proportional to its mass, and that the rate of change of the momentum of the body is equal to net force acting on the body. So Newton's second law is again a product, and you are all familiar whether it is a solid body motion or whether it is a fluid flow situation. If a fluid is following Newton's laws of motion, then the force is indicated by F equals mass into acceleration, mass times acceleration. So since force is a product in a way that it is mass times acceleration, so if I have to calculate, if I have to relate the force with the acceleration, then obviously I can take m as a constant and f will be equated as f is proportional to acceleration. And if I divide both sides by m, then acceleration will be inversely proportional to mass. So this is simple mathematical algebra that has been indicated here. The conservation of momentum principle: the momentum of a system remains constant only when the net force acting on it is zero. The use of the word net force, net, is important. That is the resultant force. If many forces are applying, then we have to take care of only the resultant force, what we may also term as the net force. That has to be zero, and thus then the momentum mv in minus mv out could be zero, that is conserved. The linear momentum in fluid mechanics, the second law, is usually referred to as momentum equation. So we can also F equal to ma, although it is called as Newton's law. That is how we famously know it. But sometimes, alternatively, we use the term linear momentum equation for this. So if I do that, you must know I am referring to F is equal to ma. And the conservation of energy principle in the same way, because energy is another thing, we will need to use it again and again in analyzing fluid flow situation, and therefore we will have to look at mathematical equation, mathematical models regarding it. The net energy transfer to or from a system during a process to be equal to the change in the energy system as a whole. energy can be transferred to or from a closed form, and it can be converted from one form to another form through heat or work. And that is within a control volume that we are considering. Control volumes also involve energy transfer via mass flow. So, the laws of conservation emphasize that all these things, mass, momentum, energy, they have to be conserved, but they can be transformed from their one form to another form by certain methodology, and that methodology is mentioned here. And conservation of energy, to be able to write it in the equation form, energy in minus energy out, since again we are talking about the rate of change of energy with time, in the rate of change of energy flowing out is obviously mathematically denoted by dE by dt, and where E is the energy that is being considered for a certain control volume. You can't leave it arbitrary. It has to be within certain limits. So that limit here is posed as control volume, because if we are integrating, if we are trying to calculate, evaluate something, then it has to be within certain limits. And if it is a linear consideration, then the lower limit of integration and above limit of integration indicates the limitation. And again, just writing it down as E rate of change of energy in minus rate of change of energy out is showing the total energy transfer into and out of the control volumes. The same thing is given here, and in fluid mechanics we usually limit our consideration to mechanical forms of energy only.